this IP addresses. Don't forget here, you can't use the network addresses of each network for assigning to the PCs, or the broadcast addresses of each network to assignings to the or using as a usable IP address in your networks. Here you know that we can use only the host addresses on each network. Here we design efficiently the for example subnets, because here as you can see we didn't waste any IP address. We subnetted one large network 192.168.10/24 with 256 IP. You know that in these networks, in the 192.168.10/24 we have 26 IP address. Subtract 2 equals to the 254 IP address, usable IP address. Now in each of these networks, okay, we have 6 bits of host. This means that we have 64 IP address minus 2 minus network address and also broadcast address, and totally finally we have 62 usable IP address. This means that we can subnet one network with 254 usable IP address to 4 subnets, with each subnet 62 usable IP address are available. Let me to calculate for you. Look at here. Totally we have 256, okay, 256 IP address. Okay, usable is 254. Here we have totally, okay, 4 multiply 64 IP address, because in each of these networks we have 64 and 62 of these IP addresses are usable, and 4 multiply 64 equal to 256. Okay, this is the benefits of the subnetting. In subnetting, with subnetting we can for example more efficiently use with our IP addressing, and also we have another benefits about the route summarization. You will learn about them in the future videos in this course. But for now, let me to say that with subnetting you can prevent from the wasting of IP address. Okay, but also here we have one disadvantage. What is the disadvantage? Look at here. When you are using 192.168.10/24, you are for example, you can't use these 2 IP addresses, 192.168.10/24 and also 192.168.1.255/24, because the first is the network address and the second is the broadcast address. We can't use them for assigning to the systems. But here you can't use 8 IP address. Look at here. The first is 192.168.10/26. The second is 192.168.163/26. This means that for each network you will you lost, and you can't use 2 address. This means that as a total we can't use 8 IP address, and this means that in the first model with the larger network we can't use only 2 IP address, but here we can't use 8 IP address. This is one of the disadvantage of this subnetting, but this is not so important for us, because in compare of the saving of IP address, this is not important for us. Here as you can see, we design more efficiently the usage of the IP addressing. This is the IP address subnetting, and in the second example, and as you can see here again we had 4 networks with the same requirement. Okay, because this is the first example in this video. Look at here. Here we can see the solution. We need 4 networks. In each networks we have 62 PCs. Again, as you can see, this is the calculation of the requirement. 2 to the power of s should be greater than or equal to the 4 networks, and because of that we need minimum 2 bits for subnets, these 2 bits, and because with 2 bits we can create 4 subnet, you know it. And after that 2 to the power of h minus 2 should be greater than or equal to the 62. This means that we need minimum 6 bits for host bits, and because of that in each network we will have 62 usable IP address. And finally this requirement is the requirement that we have 2 plus 6, 8 bits that we need, and also we have 8 bits. Because of that this should should be less than or equal to the bits that we have. Because of that, it's okay, we can design the scenario. And here you can see the design, such as our design. Let me to review it. 192.168.10/24. This means that the 24 bits are network bits and 8 bits are host bits. Now with this design, we can understand that we need 2 bits for subnet and 6 bits for the for example host. Because of that, with changing the value of these 2 subnet bits, we can create 4 new subnets, as you can see here. And finally, after creating 4 new subnet, you can change the host bits with all of the host bits 0 to all of the host bits 1. And finally, this is the result, such as the calculation that we did. Okay, after that, let me to give you one shortcut. Look at here. The first IP address, as you can see, is 192.168.10. This is the network address of the first network. After that, we have the host IP address from the 192.168.1.1 to 192.168.162. After that, the broadcast address, you know it, okay? Look at here. The first is network, then host address, then broadcast, then again the network address. This means that the network address of this network is one number less than the broadcast address of this network is one number less than the network address of the next network. Look at here. Because of that, if you find the network addresses, you can easily find the broadcast address. Only you need to subtract one number from the network address of the next networks. Look at here, 192.168.164. Here we have 192.168.163. Again, 192.168.128. Here we have 192.168.127, and also about the other networks. This is only the shortcut. It's not necessary to, for example, remembering all of this shortcut. As you can see here, we have the subnet mask of /26, 255, 255, 255, 192. This is the first example, okay? It's better to stop the video and reviewing this example. After that, you can continue with me in this video for working on the next example, the example 3 about the IP address subnetting. Okay, this is the example 3 about the IP address subnetting. Let me to read the scenario. Look at here. We have a building with 14 rooms. It's okay. 30 PCs reside in 7 rooms and 2 PCs in other 7 rooms. As you can see here, we have 14 rooms. In 7 rooms of these 14 rooms, we have only 30 PCs, and in another 7 rooms, we have only 2 PCs in other 7 rooms, okay? The task is subnetting 192.168.10/24 for these rooms. Let me to write the requirement of this scenario here. After that, we can start the designing of the IP address subnetting in this scenario. Here, as you can see, for the first time, we have 2 requirements. Let me to write it here. Look at here. We have 14 rooms. This is the 14 rooms, and in each room, in these 14 rooms, we have 2 type of requirement. In 7 rooms, we need 30 IP address. 30, we have 30 PCs, okay? And also in the other 7 rooms, we have only 2 PCs, or we need only 2, for example, IP address. Because of that, we have 2 type of requirement. You know that in all of the scenarios that in all of the 2 examples that we did before, we had only 1 requirement. For example, 4 rooms with in each room we have 62, for example, hosts. But here we have 7 rooms with 1 type of requirement, for example, 30 PCs, and also in other 7 rooms we have only 2 PCs. This is most practical example, but because that in real networks, in real work, you will encounter with this type of scenarios, this type of IP address designing, because you have, for example, some rooms with some requirement and another rooms with another requirement about the IP addressing. And also we have this range of IP address 192.168.10 again /24, and we need to design this requirement. How we can design this requirement? What is the process, what is the steps for designing of the IP addressing when we have different type of for example, requirement. Let me to say that in this type of requirements, it's better to first design the subnets with more pieces. For example, I'm going to first design this requirement. This is the first requirement. Let me to write here the requirement A. After that, after designing these 7 rooms with 30 pieces, we can start the designing of IP addressing or subnetting the IP addressing of the next requirement. Okay, it's better. You can start with the less IP address rooms, but it's better to use the more for example, more IP address rooms, and after that you can continue with the less IP address needed rooms. Okay, let me to start the part A. In part A, as I mentioned before, we have 7 rooms. In each room, we need 30 IP address. This is the first requirement. Let me to first design this part. After that, we can talk about the next part. This is the part A of our scenario. Okay, you know that first we need to find the requirement. After that, we can start the design of this scenario. The first part is 2 to the power of h, okay, minus 2 to the power of h minus 2, okay, should be greater than or equal of the, for example, 30. Okay, this is the host bits requirement, and we need minimum 5 bits for host. Okay, it's so easy. After that, we need to calculate this formula. 2 to the power of s should be greater than of the, for example, 7, because, and this is the number of bits that we need. The